Hello children, welcome to Math Simplified. This video is for 9th standard students. Today we are studying Algebra, Polynomials, exercise 3.3. We are going to cover the topics Remainder Theorem and Factor Theorem. Please subscribe and share with your friends also. Remainder Theorem. If a polynomial px of degree greater than or equal to 1 is divided by a linear polynomial x minus a, then the remainder is pa, where a is any real number. We'll understand this definition better as we do the sums. Factor theorem. If px is a polynomial of degree n greater than or equal to 1 and a is any real number, then pa is equal to 0 implies x minus a is a factor of px. X minus a is a factor of px implies pa is equal to 0. Exercise 3.3, question 1. Check whether px is a multiple of gx or not. So here is the polynomial px, x cube minus 5x squared plus 4x minus 3. Gx is x minus 2. So first we'll put gx is equal to 0 and find the value of x. And then we will substitute this value of x in the above polynomial. If it is 0, then px is a multiple of gx. If it is not 0, then px is not a multiple of gx. So let's do. We'll substitute x is equal to 2 here. We get 2 cube minus 5, 2 squared plus 4 into 2 minus 3. Simplify it, you get minus 7 as the answer, which is not equal to 0. Therefore, px is not a multiple of gx. By remainder theorem, find the remainder when px is divided by gx. Here, again we have to do the same thing. Put gx is equal to 0, find the value of x. Then substitute it in the polynomial px. Whatever value we get, that will be the remainder. In this sum, we get the remainder as 0. In the next sum, again let's find the value of x. X is equal to 1 upon 2. Substitute in px. Here it is. Solve it. Simplify it. You get the answer as 3 by 2. This is the remainder when px is divided by gx. So look at this polynomial and this is gx. Put gx is equal to 0. X will be equal to 3. Put 3 in the polynomial. You get the value 62. This is the remainder. Okay, here also the same sum. Find the remainder when this polynomial is divided by x plus 3. Put x plus 3 is equal to 0. X is minus 3. Here we are putting minus 3 in the polynomial. Then solve it. You get the answer as minus 143. It is the remainder when this polynomial is divided by x plus 3. What is the remainder when this polynomial is divided by x minus 1? Again the same method. Write x minus 1 is equal to 0, x is equal to 1. Substitute here x. So 1 raised to 2018 is 1 only. So 1 plus 2018. So the answer is 2019. For what value of k is the polynomial exactly divisible by x minus 2? Same method. Write down x minus 2 is equal to 0. Now the polynomial is exactly divisible. That means when you put 2 here in this polynomial, it will be equal to 0. So now you simplify it, is equal to 0. So 4k is equal to 32 and k is equal to 8. If two polynomials leave the same remainder when divided by x minus 3, find the value of a and also the remainder. The same method, first put x minus 3 is equal to 0, find the value of x. Then substitute this value in the first polynomial. you will get the first remainder. See, here it is. I've substituted in the first polynomial. I got the remainder as 54 plus 9a. Okay. Now substitute x is equal to 3 in the second polynomial. I get the remainder 30 plus a. Now these two remainders are equal. So if you solve this, 8a is equal to minus 24 and a is equal to minus 3. Substitute here again and you will get the remainder as 27. Determine whether x minus 1 is a factor of the following polynomial. Again, do the same method. X minus 1 is equal to 0, x is equal to 1, and substitute in the polynomial. Simplify it. The value is equal to 0. Therefore, x minus 1 is a factor of the above polynomial. Using factor theorem, show that x minus 5 is a factor of the polynomial. Same type of sum. Put x minus 5 is equal to 0. Value of x is 5. In this polynomial, put x is equal to 5. Simplify this. Open the bracket. If you solve this, you get the value 0. Therefore, x minus 5 is a factor. Determine m if x plus 3 is a factor. So here it is a factor they are saying. So write down x plus 3 is equal to 0, x is equal to minus 3. Put the value in this polynomial. It is a factor, therefore it will be equal to 0. So here you get this minus 27 plus 3m plus 24 is equal to 0. So 3m is equal to 54 minus 24. 3m is equal to 30, m is equal to 10. If both x minus 2 and x minus 1 upon 2 are factors, show that a is equal to b. Again the same sum. Find a value of x here. Value of x is 2. So put 2 in this sum. That will be the remainder of the polynomial at x is equal to 2. Then find the remainder of this polynomial at x is equal to 1 upon 2. And both are factors. So both the remainders are equal. So see here. I found the remainder of the polynomial at 2. This is the remainder. And here the remainder is this value. Both are factors. So both are equal to 0. Both will be equal. Then see, I've written it down. Both are equal. Then you simplify this. You get 3a is equal to 3b. Hence, a is equal to b. If x minus 1 divides the polynomial without remainder, then find the value of k. Without remainder means the remainder is 0. So, again, write x minus 1 is equal to 0. The value of x is 1. Put the value of x 1 here in this polynomial and simplify it. See, I have put the value of x as 1. Here 1 I have put and I have simplified it. I get this expression. This is equal to 0 because it divides without remainder. The remainder is 0. Then simplify this. You will get k minus 3 is equal to 0. K is equal to 3. Check if x plus 2 and x minus 4 are the sides of a rectangle whose area is x square minus 2x minus 8 by using factor theorem. So here we have to check if this is a factor of this polynomial. Okay. So how do you check? Again put this is equal to 0. The value of x will be minus 2. Substitute minus 2 in the polynomial. Solve it. You get 0. So x plus 2 is a factor of px. Again put this x minus 4 is equal to as 0. The value of x is 4. So right now find out P4, take 4 and put it in this polynomial and write down whatever values you get. You find that it is equal to 0. So x minus 4 is a factor of px. Therefore, x plus 2 and x minus 4 are sides of a rectangle whose area is x squared minus 2x minus 8. So here we come to the end of the video. And please go through the video once again. Pause the video in each sum. Look at the steps that I have written and practice the sum.